Uh, Today, so we have already studied ionic bond, and today we will discuss the next important bond, that is covalent bond. And today's discussion includes the details about the covalent bond, how the covalent bond forms, and the specific example of diamond. And it is specially we will discuss to show that the covalent bond is a directional bond. Okay, so when two atoms came together and in their orbitals have specific directions, overlap in the specific direction, then only there are 100% chances of formation of the bond. And the best example is diamond that we will discuss. And at last, we'll see the properties of the bond. And here we'll start with the next slide. Okay, so let me start with the covalent bond. So we have seen that it is the ionic bond that is formed by the transfer of electron. Okay, so electron transfer from one atom to other. Okay, what happens is that the electron, one atom loses its electron while another atom gains the electron. The atom which loses electron, it becomes electropositive. That means a positive ion. Okay, no longer it remains atom. It becomes positive ion, and the atom which gains electron, that becomes electronegative. That is negative ion, and the electrostatic attraction between the two ions, that is one positive ion and negative ion, okay, that is responsible for formation of a bond that is called as ionic bond, and the corresponding crystal is called as ionic crystal. Now here there is one another criteria that is responsible for another new type of bond, uh, uh, that is a covalent bond. And what is criteria is there? Here, there it was transfer of electron in case of ionic bond, and here it is what? Sharing of electrons. That means here there is no transfer of electron, but this bond is formed by the equal sharing of electrons between two neighboring atoms, where each having incomplete outermost shell. Okay, outermost shell, that means valence shell. Okay, so if two atoms came near to each other, okay, which have equal deficiency of electron, then their orbitals, outermost orbital shares equal number of electrons. For example, shares a pair of electrons to the common space in between them, and the bond is formed. That type of bond is called as covalent bond. So one thing is clear, that covalent bond is formed because of the sharing, equal sharing of electrons between the two neighboring atoms. Okay. Now, question is why the atoms will share the electrons. The simple thing is that their their electronic configurations are not stable, and to complete their octet and make their electronic configuration stable, okay, they share the electrons. After equal sharing of electrons, their electronic configurations become stable, okay, according to the octet rule. That means their octet is completed and they become stable. Okay, now important thing is that why there is not a transfer of electron between these atoms? Why there is a sharing? The answer is that in case of sharing, we observe that, let us take, for example, the example of NaCl crystal. Now, Na atom, we have studied that the electronic configuration of the Na atom is in such a way that it has only one electron in its outermost shell, while the chlorine atom, okay, has a lack of only one electron. So in order to complete its what do you say, in order to make its complete its octet, or in order to make its electronic configuration stable, so simply one electron from sodium, okay, migrates transfer to the, what do you say, chlorine atom, and the sodium atom becomes sodium ion, and chlorine atom becomes negative chlorine ion, and the bond is formed. But if the two atoms came near to each other in such a way that both the atoms have equal deficiency of electron, then such type of transfer is not possible. Because, for example, both the atoms are there and both require one electron to complete their octet. Then whether the transfer is possible? No, transfer is not possible. In that case, only the situation is that both the atoms must share an electron, and okay, the shared pair will complete the octet of both the atoms, and in this way the bond is formed. So since both the atoms have equal deficiency of electrons, okay, there is no transfer of electron took place in case of the atoms, okay, of the covalent crystals. And since there is no transfer of electron, so there is no charge associated with the atoms, because we have seen that if an atom loses its electron, then it becomes electropositive, it acquires a positive charge, becomes positive ion. While the atom which gains the additional electron, then it becomes electronegative and acquires negative charge, becomes negative ion. But since in case of sharing of electron, there is no transfer of electron, so there is no chance of conversion of atoms into ions. So no charge is associated with atoms. Atoms remains atoms, and the pair in between them bonds the atoms together, and such type of bond, which is formed due to sharing of electron between two neighboring atoms, having incomplete outermost shells, that is called as a covalent bond. Important one is that there may be a question in your mind that if both the atoms have equal deficiency of electrons, that means the atoms are of the same element. Okay, for example, two sodium atom or two chlorine atom. Okay, is it the case? No, it is not always. But if these are not not the similar atoms, okay, then also the covalent bond will form. That means the covalent bond may be formed due to sharing between similar or dissimilar atoms also. Okay, only the necessary condition is that both the atoms must have the equal deficiency, deficiency of equal electron. Both the atoms must have deficiency. Okay. There should not be a situation that one is efficient in electron, another is deficient in it. In that situation, there will be a transfer of electron, not a sharing. Okay. So this is the important condition. So covalent bond may form between the similar or dissimilar atoms, okay, having equal deficiency of electrons. Okay. Now, how the sharing took place? So what is the criteria behind sharing? See what happens when atoms are at, say, well separated at certain distance, then there is no possibility that there is sharing of electron. But when the atoms become so close to each other, that their shells overlap on each other, in that case the electronic configuration of both the atoms will, what you say, distorted, and they share their unpaired electron to the common space in between them. Okay, unpaired electron to the common space in between them. Okay, and pair of electron, this pair of electron, okay, will serve to complete the octet of, or serves to stable the electronic configurations of both the atoms according to the octet rule. That means a pair of electron is common to both the atoms, and the pair will remain in between these two atoms only. Okay, so since sharing is effective, if the shared electron have opposite, so this is the important thing, that the sharing of electron is effective if the paired electrons, so the paired electron have opposite spins. Okay, if you are, okay, possible, if it is possible to observe my fingers, then you will find the opposite spins. Okay, so this is the situation. Okay, so if they have opposite spins, then and then only the there is a strong possibility of formation of the bond. Okay, so this is totally the sharing of electron. Now, how sharing is possible? When two atoms came near to each other in such a way that their orbitals, outermost orbitals overlap on each other and their electronic configurations disturbs, or what you say, disturb for certain time. Okay, and in this situation they share a their unpaired electron, and a pair of electron is formed in between the common space between both the atoms, and this pair of electrons serves to complete the octets of both the atoms and make both the atoms stable, electronic configurations of both the atoms stable. Okay, and the formation of a bond is, especially the sharing of electron is effective when both the electrons have opposite spins. In that case attraction is possible and bond is formed. Okay, so this is the situation, this is sharing of electron. Now there is one point is there, that since both the electrons both those are shared belongs to the same valence state of both the atoms. So this bond is also called as valence bond. So another name for covalent bond is valence bond, and that is because the electrons making a pair belongs to the same valence state of both the atoms. So uh, let us have the example. Okay, it will be more clear if you look at the example. For example, let us consider that two chlorine atom, they came so close to each other that their outermost orbitals overlap on each other. Now, what happens is here that in the outermost shell of the chlorine atom, they have three electrons. That means one electron is unpaired. One electron of each chlorine atom is unpaired. So these are unpaired electrons. And so uh, their balance, their what you say electronic structure gets disturbed, and they share their unpaired electron to the common space in between them, and in this way the pair of electron is formed, and this pair of electron will serve to both the atoms to complete their outermost shell, or to complete their octet, or to make stable their electronic configuration according to octet rule. Okay, so the shared pair of electron is common to both the atoms. This is not the property of a single atom. While in case of ionic bond, the one electron is totally transferred from one atom to other, and that electron belongs to that corresponding atom, and it becomes negative. Here it is not the case, that here the pair of electron is common to both the atoms. So this is the situation. Another, so this is the formation of bond between the two similar atoms. Now here it is the formation of covalent bond between the three dissimilar atoms, or two dissimilar and one dissimilar. So two H atoms are there and single oxygen atom. So H atom has a single electron, and that serves as a valence electron, which is unpaired, of course. And what about oxygen? Oxygen atom has 4 plus 2, that is 6 electrons. That means 4, 2, 2 makes their pair, while 1 each, that will not make a pair, and it will pair when the two hydrogen atoms came near to each other. Okay, so this is a shared pair. This is the shared pair, and oxygen molecule is formed. Okay, so this is again a covalent bonding between H and O, H and O. Okay, so the covalent bond is formed between the similar or dissimilar atoms. Only the condition is that both the atoms must have deficiency of electron. So now, so we have seen the sharing, we have seen the example, and now let us see how many number of atoms, covalent bonds are possible between the two atoms. Okay, what is this? Okay, now let us look at here. We have seen the single covalent bond that has been formed between two Cl atoms in the previous, and again, now let us look at a double covalent bond. See, in case of chlorine atom, both the atoms have deficiency of a single electron. But if it is the situation that both the atoms participating in the covalent formation of covalent bond has a deficiency of 2 electrons, then what will happen? Then in that case, double covalent bond will form. Okay. the two pairs will form, and this belongs to double covalent bond. For example, if two oxygen atoms came near to each other, then what happens? Both the oxygen atoms have two unpaired electrons. Okay, so two pairs of electrons are shared by both the oxygen atoms, and a double covalent bond is formed. Okay, so is there any possibility of triple covalent bond? Yes. If the atoms participating in the formation of covalent bond have deficiency of three electrons each, then a triple covalent bond will form. And the best example is the nitrogen molecule. Okay, so each nitrogen atom has three unpaired electrons. So the three pairs will be formed, and in this way, triple bond is formed. So how many? So how will we decide that when two atoms came to near to each other, how many bonds will form? And that is decided by the 8 minus n rule, where what is n? N belongs to the number of columns in the periodic table to which the atom belongs. For example, the oxygen atom belongs to sixth group. What will be the 8 minus n? So 8 minus 6, where 6 belongs to the group in the periodic table to which oxygen belongs. So 8 minus 6 equal to 2 covalent bond. So the oxygen atom, when oxygen atom came to near it came near to each other and formed the covalent bond, there will be a pair of covalent bond, two covalent bonds. Okay, so 8 minus n rule is there. So double, triple, all bonds are possible in case of the formation of covalent bond, and it is decided by 8 minus n rule, where n is the number of column of the periodic table in which the atom is situated. Okay, and we have seen the example of oxygen, where oxygen is in the sixth group. So 8 minus 6 equal, it performs 8 minus 6 equal to 2 covalent bonds. Now, important thing is the directional property of the covalent bond. Okay, now, formation of covalent bond, a stable covalent bond. If a stable covalent bond is formed, then there is decrease of potential energy as a result of mutual sharing of electrons. Okay, so decrease of potential energy is the main criteria behind formation of. Okay, because after decrease of potential energy, the system, after sharing, the system becomes stable. That means the stable covalent bond is formed. Okay, and this is possible if the orbitals, outermost orbitals, may overlap effectively. Okay, and it is okay happen if the vacant electronic states are available in the outermost orbital and they overlap effectively. Okay, vacant means they have deficiency of electron. That is the thing. Okay, now this overlapping of orbital is effective when the orbitals are directionally oriented. They belong to specific direction. They are oriented in the specific direction. Then and then only their overlapping is possible. Okay, and due to which you will find that covalent bond, when two atoms came near to each other and they have their directional orbitals, okay, the overlapping is successful and the covalent bond is formed. That means when two atoms came near to each other and the bond is formed, covalent bond is formed, that will form in a very specific direction. Okay, so the covalent bond is formed in the specific direction because that is the direction of the orbitals, because orbitals are directions. Orbitals are directionals. Okay, so covalent bond is also a directional bond. It took place in the specific direction, and out of which sp, d, g, which orbitals are directional. The chemistry tells us that p orbitals are directional in nature, and since they are directional in nature, they took place or they participate in the formation of covalent bond. So important thing is that covalent bond form in the specific direction, and that direction is decided by the p orbital, which is directional. Okay, because if the directional orbital will overlap, okay, the overlap will effective and bond covalent bond will form. So since p orbitals are the orbitals we took participate are what you say directional, so covalent bond is a directional. It took place in the specific direction. Now, the directional property, in order to explain the directional property of a covalent bond, we took the example of diamond. Because diamond In diamond, we will find the good manifestation of the directional properties of the covalent bond. Now, the ground state electronic configuration of a diamond, of a carbon from which a diamond is formed, diamond crystal is formed, is 1s2, 2s2, 2p2. So, six electrons are there. So two belongs to 1s state, two belongs to 2s state, and last two belongs to 2p state. And you will find that in 2p state, there are two unpaired electron in the outermost orbit. Now, if these are the unpaired electrons, so what happens when the another carbon atom came near to having the same, okay, that will came near to each other. Now, what happens is very interesting one. So, as far as physics is concerned, this 2s orbital and 2p orbital has nearly the same energy. Okay, so the energy difference between the 2s orbital and electrons present in the 2s orbital and 2p orbital is very small. So, the electron from 2s orbital can easily migrate to 2p orbital of the same carbon atom, and the electronic distribution that will change, and that will change to this one. Okay, so 1s2 will remain as it is, and from 2s orbital one electron will move to 2p orbital, so it is only 2s1, and 2p orbital will split up into three 2p orbitals, that is not split up, but for our criteria let us consider it as split up, and 2px1, 2py1, 2pz1. So in this way there are four unpaired electrons. So these are not two unpaired, but these are four unpaired electrons. And what happens that when another carbon atom with the same four unpaired atom came near to each other, that is two. So in that case, it will both will this carbon atom will make bond with that carbon atom in the specific direction. So the carbon atom, this carbon atom to share these four unpaired electron require another four carbon atoms. Okay, four neighboring. So the bonding will complete when four neighboring carbon atoms will came near to this carbon atom, and four covalent bonds will be formed. And important one is that all these covalent bonds are of equal strength with a very specific angle between the two, what you say, carbon bonds, CCCC bonds, and that is equal to 109 degree 28 minutes. Okay, now how will we explain this situation? Okay, so the bonds are formed, four bonds, single carbon atom create bonds with the four carbon atom. Each bond is of equal strength, and there is a specific angle between the two bonds, and that should be 100, that should be perfect, and that is equal to 109 degree 28 minutes. Now, how is this possible? This is possible. Okay, if we consider the next the one consideration. Okay, that we have seen that in the previous slide, the 2s orbit and 2p orbit, okay, the electrons of 2s orbit and 2p orbit take part in the formation of the bond, in the formation of the bond. So this is, so 3p orbit and 1s orbit, so this is called as hybridization of the orbits. So and the corresponding orbital that has been formed or the electron is called as sp3 orbit. So 1s and 3p orbits. So in this diagram, this is the sp3 orbital. Important one is that I have told to you that p is a directional orbital. So it will make sp3 four sp3 orbitals along the four corners of a tetrahedron. This is the diagram of tetrahedron, and you will find that sp3 orbitals are along the four corners of a tetrahedron, and in such a way that the angle between the two tetrahedrons is equal to 109 degree 28 minutes. And in this situation, when another tetrahedron, another carbon atom will came near to each other, okay, so this sp3 will overlap with that sp3, and the overlap will took place in these directions only, and the perfect angle is maintained. So the this is the good manifestation and good explanation of how the covalent bonds are a directional one. And in this way, the 3D network is formed, okay, and the diamond crystal is formed. So this is the unit cell of the diamond crystal, which we have discussed in detail. That it has FCC and what you say tetrahedral white positions, and at both the position carbon atoms are present, and it is due to the tetrahedral white positions, the FCC, which is a close packed, that becomes loose packed. So since these positions are occupied by this carbon atom, okay, so this becomes loose packed structure. Okay, so this is, and all details we have seen in the previous unit cell details we have seen in the previous chapter while looking at the diamond structure. And here uh, we will have the properties of the covalent bond here, because we are dealing with bond. See, the covalent bond, the crystals possessing covalent bond, that is covalent crystals, are the hard and brittle crystals. Why? Because the bond is so strong that the binding energy, that means energy released during formation of the bond, single bond, is 7.4 electron volt. And generally, if the energy released is in the range of 5 to 10 electron volt, it is a strong bond. Okay. Same was the situation in case of ionic crystals. So covalent crystals are strong. And the hardest possible material on the surface of Earth, that is diamond, okay, that is a covalent crystal. So you can imagine the hardness of the covalent bond crystals. Since these bonds are strong, so high thermal energy is required to break the bond. So they have high melting and boiling points. Okay, so the crystals have high melting and boiling points. And another example, another property is that since the bonds are very strong, so electrons will not be available for formation of the bond. So, electron will not be available for the formation of the conduction of the current, and therefore the covalent crystal has low conductivity, especially at room temperature or normal temperature, and this conductivity will increase very slightly with the temperature. Okay, and different examples of covalent crystals other than carbon are silicon, germanium, alpha tin, etc. etc. These are the examples of the covalent crystals. Certain covalent crystals are very important because they have moderate binding forces and they behave as a semiconductor. And this is quite interesting. And the examples of silicon and germanium. Silicon and germanium are the semiconductors, okay, and they give rise to the branch of electronics that has changed the face of humankind. Okay, so these are very important bonds and important crystals. Okay, so we have seen, and the topic is open for the discussion, and